Firstly, my name is Suresh Seetharaman. Thanks so much. It's an awesome audience, and it's the first time at ACD for me. Thanks to Sanchit. He was the one who talked to me and guided me about this particular event, and I'm very excited to be out here. So I've just joined Yugabyte in December as their country manager. Prior to that, I used to be in AWS, heading the database business. How many of you here have heard of Yugabyte before? My God, okay. I have an uphill task. Okay. How many of you are familiar with the concept of distributed databases? Okay, that's great. So that's encouraging. So I come with a long history in the database space, and I personally am very passionate about databases. I believe that a database is like a human heart. You don't see the heart. If there is an issue, you feel it everywhere. A database is also in the same sense. It's not seen, but if it acts up, everybody feels it, and it's often taken for granted. So I just want to start with this preamble and slowly build on to the story. And trust me, I'm not going to go deep into Yugabyte. 15 minutes will not, I won't be able to do justice in 15 minutes, but this session is going to be more like a teaser, and I'm sure you're going to go back with what is Yugabyte, what problems it solves, and how can you gain from Yugabyte. How many of you have read this book? Very few. It's an epic book. So the point I'm trying to drive here is that a lot of companies have actually grown and they've all evolved. But does it really mean that the technologies that served us until now will help us in meeting our future ambitions? Perhaps not. History says companies like Intuit, companies like Adobe were able to see ahead of the corner or the curve, and they were disruptive. They reinvented the business. Some companies like BlackBerry were left behind. So the point I'm trying to make here is that while your databases, which are very, very critical, may have served your business so far, does it make sense to continue with the same databases for future? Maybe not for everybody, but for a sliver of customers. Now, having met with hundreds and hundreds of customers across India, you talk to any of them, you're going to get a few requirements about databases. What do you expect in a database? Some are going to say scale. They're going to talk about performance. They're going to talk about low latency. They're going to talk about security. They're going to talk about resiliency. There's a whole bunch of features that people expect. If you prioritize this list, and based on what's happening globally in the last 2 years, what we're seeing is that we're seeing about 3 trends emerging. The first is scale. And I'll talk about each one of this. The second one is resilience. And the third one is price performance economics or cost. Now, when I talk about scale, there is a misconception. Hey, there are NoSQL databases. It offers scale. Now, I can cook in my kitchen, I sleep in my bedroom, but I don't mix the two. Same way, if you have a transaction database and you want to run it on NoSQL, it's a strict no. You got to run on a transactional databases or what is popularly called as a relational database. Even today, the relational database market is over 3/4 of the total database market. While people may say it is a dinosaur, it's not. It's there to stay, and it has a purpose to serve. Now, In the scheme of things, if someone were to use a NoSQL database, I'm perfectly fine with NoSQL database for a LinkedIn post or a Facebook post. I may post something, you may see the old post, they may see the new post, but that's fine. But if I'm running a retail, my inventory is 0, but my transaction is not showing 0, it's still showing 1. I end up selling it, it's a problem. If I made a transfer, like what happened to Flexcoin and Polonix, you ended up overdrawing money. So, talking about scale, what's the problem with scale? Now, a large part of the database market, at least in the relational world, is MySQL and Postgres. What are the challenges with Postgres? They're wonderful databases, perfectly great. It serves a large majority of customers. But do companies remain the same? They evolve. Maybe when I start an operations, I'm okay with a downtime. I can afford to spend about 2 days, or 2 hours in the night to perform an operation. Once you reach a certain scale, it's not. Now, scale is something in a similar sense. Some companies, they hit a tipping point. How many of you here have heard of CII? It's by MITI. It's called Critical Information Infrastructure. Banks like ICICI Bank, HDFC Bank, and SBI, they are all part of CII, which means that they are a national asset. So their resources are very, very critical. Now, when you reach a certain scale and you're not able to operate, you cannot do it in MySQL or Postgres. What do? You can only scale vertically. And what are the limitations with vertical scalability? You can go up to 48 cores or 96 vCPUs or 128 vCPUs. That's about it. What about more? It's a challenge. So what have some companies done to avoid it? They've done something called as database sharding. I create 10 databases, database 1, 2, 3, 4, 10. My record will hit one database, someone else's record will hit a second database, a third person will hit another database. But that adds operational complexity and it is unnecessary. Here is an example. I'm going to talk through one customer example so that you get an idea. CBS Sports is actually part of Paramount Plus. And Paramount Plus in 2021, they got the streaming rights for Super Bowl. And for those of you, how many of you know Super Bowl? It's like the BAP of IPL. It's probably on the same levels, if not much greater, in the US. And there are about 3 or 4 streaming companies, Comcast, CBS, Fox, ABC, and all that. They get it in a round-robin table. I mean, every 3 years, they rotate. So in 2021, when an event happens, in the first 10 minutes when the event starts, everybody is logging in and registering. And your system is unable to handle it. They were running on MySQL. And they had major outages. 2024, in the last 3 years, they wanted to change it. They knew that the turn is coming up in 2024. They wanted to do something different. After evaluating many databases, they chose YugaByteDB. And we clocked about 124 million users. And when I say 124 million, it's about in the 10 minutes. Everybody gets in. It's like an IPL. So that's the level of scale that YugaByteDB can manage. Limitless scale. Sometime in January, December end, January timeframe, the Deputy Governor of RBI, Mr. J. Swaminathan, he made a fascinating speech. And one of the things he said, the crux of the message is, the message to the banks, invest like there is no tomorrow. What did he mean by that? He was trying to emphasize that you have to emphasize on business continuity. How do you create a system that cannot fail? Today, you take MySQL or Postgres, you have an active-passive setup. You want a software update, you want to apply a patch, any operations, it means that you have to bring down your database, There will be a finite downtime, could be 5 minutes, 10 minutes, half an hour, but there is a downtime. What happens if the entire region goes down? How do you manage it? Now, is there a system that can help you tide over downtime and give you zero downtime? And that's where resiliency comes into play. Now, CBS Sports also wanted that. They wanted to ensure that they did not suffer with a regional downtime. Now, Yugabyte by default, we start with a minimum replication factor of 3. That is, we have multiple nodes, and minimum is 3 nodes. You can go scale up in odd numbers. And CBS went with one of the options, which is called a stretch cluster. Let me translate it for AWS in India. We actually did it. I wanted to run a demo today, but I couldn't. You could run a database cluster that is across Mumbai, 2 availability zones in Mumbai and Hyderabad. It's one database. You bring down any server, nothing's going to happen, it's still going to work. So that's one config. And this is what CBS employed in order to ensure they had no downtime. We support another configuration called X cluster. You can have one cluster running in Mumbai, another cluster running in Hyderabad, and the 2 of them, you could have a bidirectional or unidirectional async replication. Trust me, I've been in databases for 27 years. I don't think anybody here is able to do it. And this configuration is today employed by one of the largest brokerages in the world. It's used by a fintech in APAC. In India, one of the largest banks uses Yugabyte with this configuration for UPI. So we have 2 configurations. This allows you to run your database with no downtime. Now, this is a blog post. The customer is not named. It's one of the largest retailers in the world. They run using one of these 2 architectures, and they were able to tide over an entire region outage. A region outage, an entire Texas region went down in February 2021. They were able to tide over it. They didn't see a blip in the operations. The last part, I talked about scale, I talked about resiliency. Now, what's happening in the last 2 years? Now, until 2 years ago, it was a dream world. Money was flush. The mantra was growth at all costs. But what's happened is now in the last 2 years, it is profitable growth. Every company I talk to is, how do I optimize my cost? Now, to attain scale and resiliency, it's not like you have to pay a bomb for it. Can you ensure that you get these requirements at a reasonable cost? And that's why I call it the price performance economics. Now, and when you look at it with Yugabyte, it's not going to be cheap. I'm not saying that you can compare it with, say, an open source database. We are open source as well, so that's the first point. Yugabyte is an open source database. However, when you look at price, it's not just the cost. You need to look at the value. What are the values you derive? If assume that you're maintaining, I know a customer who employs database sharding, has 300 databases to manage their one application. And if you wish to achieve that, imagine the operational overhead, the developer productivity, infrastructure efficiency. Then, like in the case of CBS, if you have an outage, you're going to lose revenue. You're going to lose, customers are not going to come in. If you're a retail customer, they're going to go to somewhere else. The revenue gained or the revenue loss avoidance. When you factor in all this, Yugabyte offers you a compelling price performance economics, unmatched. And one of the reasons why we are seeing increasing adoption with a large number of enterprises. And one more interesting fact, so that one of the unique features we have is something called as geo-pinning. So I have this point here called regulatory compliance. CBS also employed it. You have customers coming from all over the world. How do you have your European data in Europe, American data in America, Asian data in Asia in the respective countries? You can achieve that with geo-pinning. And that's another compliance requirement that is much easily achieved here. So first thing I wanted to talk to you about was essentially what is the industry looking for, and companies should look at how they achieve their future ambition with new technologies. You can't rest on saying that something has worked and hence it will work in future. So what is Yugabyte? Yugabyte is an open source database. It's a distributed SQL database. It runs on all clouds. It runs in on-premise. It's written in C++. It supports two APIs, PostgreSQL and Cassandra. We've had customers who've used Cassandra. They wanted to cut cost. They wanted to get transactional consistency. And one more important thing, this is not a NoSQL database. It is a transactional database that supports ACID. So customers have moved from Cassandra, using the Cassandra API. A large number of customers are actually moving from Postgres into Yugabyte. So there is a video, there are two videos. I wanted to run a video here, but it'll take a long time. You can come down to our booth. Mastodon is an open source equivalent of Twitter. It's written in Postgres. So we have a YouTube, 2 bite-sized videos, about 2.5, 3 minutes. You can actually, the video shows we've downloaded Mastodon from GitHub, compiled it on Yugabyte with no code changes. And it runs perfectly fine, same level if not better. The second video talks about scale and resiliency. The system is pounded with a lot of users, and they bring down one node. Nothing happens. The application doesn't even see a blip. So I urge you to look up these videos. And so I just want to leave, you can, whenever you get a chance, do look up our YouTube videos. So it's an open source database, distributed SQL, supports 2 APIs, Postgres and Cassandra SQL. Built-in resiliency, that's what I talked about in the beginning, limitless scale, and geo-distribution, which is now becoming an increasing requirement, especially in finance. So we have 3 options. One is the open source. You could download it. Feel free to go to yugabyte.com, download Yugabyte, and we have a Slack channel. Feel free to register in the Slack channel and post questions. All your queries can be answered. We have a Yugabyte Anywhere that you could deploy it in your EC2. You could deploy it in your on-premise. We also have a managed offering that is available on all the hyperscalers. This year, recently, we got recognized by Gartner as one of the top 20 database vendors globally. And one of the points that, or the salient points that they highlighted was amongst the distributed SQL databases, we have the highest level of compatibility towards Postgres. So what's under the hood? So I talked about Yugabyte, scale, resiliency, and cost. Open source, runs on any cloud, runs on-prem. You can run it self-managed, you can run it managed. So what's under the hood? So at the foundation is we have a customized database. We have a storage engine, we call it DocsDB. It is customized RocksDB. Now our founders were the creators of Cassandra at Facebook. So Kanan, Karthik, and Mikhail, all of them along with Avinash Lakshman and Prashant Malik created Cassandra at Facebook, and they also were leading contributors to HPace. So they bring a deep database expertise into building Yugabyte. So the first thing is we have a storage engine that's built on RocksDB. We call it DocsDB. On top of that, we have 4 layers. One is Raft Consensus Protocol. How many of you are familiar with Raft Consensus Protocol? Cool. So let's say three of us, we want to pick which movie do we want to go to. What do? There are two movies, we probably vote. It's election time, everybody knows what it is. I have to rush through, I have just 2.5 minutes, okay. So you vote. So what we use Raft for, and pretty much most vendors or most database companies in the distributed SQL use Raft, is when you're making database changes, how do the different nodes agree upon the change to ensure that the data is consistent and durable, and there is integrity maintained. That is what we use Raft for. The second is sharding and load balancing. I talked about database sharding. What is sharding? Let's say you have a pizza. You just slice it down. You don't want to gulp the whole thing. So how do you slice data so that you could distribute it? Load balancing is you don't want everything to land in one node, one plate. How do you distribute it evenly? So that's another engine that is above the RocksDB. The third one is distributed transaction. I have multiple operations across multiple nodes. How do I ensure that they all commit simultaneously together? If not, they fail together. You can't have one node writing, the other one failing. You can't have it, so you need a distributed transaction layer that ensures consistency of data. And the last one is workflow engine, which is a database does hundreds of tasks. How do you prioritize them to make sure that you get the best database experience with efficiency and effectivity? I talked about the API layers. We also have the standard database layers in terms of security. How do you keep your data safe, secure? Identity access management, who has access to what data? And we also have the infrastructure and orchestration, which is essentially about the harmony between the software and the storage. Software and the hardware. How do you make sure that it works really seamlessly well? And a GUI that can manage the entire database operations. Now, I just skipped this slide. The last slide is where distributed SQL operates in. But I want to just run this one so that it leaves you in this thing. Let's say I want to make a change. It goes into shard 1. Now, what happens with Raft consensus protocol is that shard fans it out to the other two shards, or the tablets, we call it tablets. One of them, whoever writes it or makes a change first, is going to send a confirmation back. And once that confirmation is received, your application receives the acknowledgement that the transaction is complete. This is how we maintain the asset nature of transactions. Where could you use Yugabyte? You could use it for net new workloads. If you have databases, and you want to modernize a database from Oracle, SQL Server, Postgres, you could consider Yugabyte. If you want to build edge applications, you could actually seed Yugabyte into cloud-native applications, even in Kubernetes. You could actually have Yugabyte running in Kubernetes. Now, some open source applications that work out of the box on Yugabyte, they're all written on Postgres, but we've tested them to work successfully with Yugabyte. Customers, a large list of customers. In India, we have eminent banks using Yugabyte in some way, form, or shape, either CBDC, UPI, IMPS, and we're seeing more and more traction now. We've even some fintechs, but globally we have customers like Wells Fargo, Fidelity, Charles Schwab, Walmart, Kroger's. In APAC, we have Tokopedia. In India, HDFC Bank, SBI. So a large number of customers, and as you see here, most of these customers are enterprise customers who actually need the scale, resiliency, multi-cloud, and a geo-distributed nature of database. I'll just stop here. My time's up. So maybe 1 minute, 1-2 minutes? Okay, 2 minutes. Any questions?